Okay, in this section, we're going to be talking about multi-stage experiments with tree diagrams and geometric probabilities. Now, tree diagrams can be a lot of fun. They can also be a little bit cumbersome. So let's talk about them, what they are first, then we'll talk about well, I think you'll see as we're going through it, kind of the advantages and disadvantages of trying to always use a tree diagram. Okay, I said tree diagrams are extremely helpful when you want to get a picture of what it is that you're looking at. So just a visual representation of some sort of events. So I said, let's say, for instance, that we have three colored balls in a bag. There's a yellow one, a green one, and a red one. And we want to know what is the probability of picking a yellow ball, a green ball, and a red ball in that order with replacement and then without replacement. Okay, so when we're talking about with replacement, we mean as we reach in and pick out the first ball, we want to pick out the yellow ball. Now with replacement means then we want to put the ball back in the bag, so now we still have three balls in the bag, and now we want to pick out a green one, and so on and so forth. Without replacement means that you want to reach in and pick out the yellow ball and then set it to the side and not put it back in the bag, not replace it. And then, so now you only have two balls left in the bag, and now you want to reach in and pull out the green one and then set it to the side so that you only have one ball in the bag. Does that make sense, the difference between with replacement and without replacement? Okay, let me show you what a tree diagram is, and especially in this situation. First of all, we start off with what we have. We have a yellow ball that I'm going to put a big Y for, and then we have a green ball, which I'll say G, and then we have a red ball, which I'll call R. So these are in the back. Now, if we pull out a yellow ball to begin with, and remember this time is with replacement. So if I pull out the yellow ball, I'm going to put the ball back in the bag, and at this point then I could either pull out a yellow, a green, or a red again. You see how I'm making this tree with branches? That's why it's called a tree diagram. Now, depending on which one I pull out, I'm going to put it back in the bag, and then I'd have the possibility of a yellow, green, or red, or a yellow, green, or red, or a yellow, green, or red. What this does is it helps you to figure out the sample space of all of the different possibilities. So far, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities in just this first scenario. Now, we would need to go through and finish out our tree diagram, because what if we picked out the green ball first, and then we could get a yellow, a green, or a red, and then so on and so forth, a yellow, a green, or a red, a yellow, green, or red, and a yellow, green, or red. Now we have 18 different possibilities in our sample space, but we haven't even taken into consideration the red ball yet. So if I choose a red one first and then put it back in the bag, we could pick out yellow, green, or red, and then yellow, green, or red, yellow, green, or red, and then yellow, green, or red. So in order for me to choose yellow, green, then red, that would be this possibility right here. So that would be one success out of a total of 27 possibilities. Now, this is one way that we can look at this. We're also going to look at another way to do it. But tree diagrams can be very helpful if you need to be able to see what it is that you're working with, see all the different possibilities, but it can be a little bit cumbersome also. Now let's talk about without replacement. because that's a little bit easier to deal with. Let's start off with we either have a yellow, a green, or a red ball in our bag. Now, if I pull out the yellow one, I'm not going to replace it back in the bag, so the only choices that I'll have left will be a green and a red. If I pull out the green one, the only one I have left is red. If I pull out the red one, the only one I have left is green. So when we're talking about not replacing these balls back in the bag, we have much smaller sample space than we did with replacement. If I pull out the green ball first, then I could pull out a yellow or a red next. If I pull out the yellow one, I'm left with red. If I pull out the red, I'm left with yellow. And then lastly, if I should pull out the red ball first, then I would have yellow or green left in the bag. If I pull out a yellow one, I'm left with green. And if I pull out a green one, I'm left with yellow. So here, my sample space is now down to 6 possibilities. And the yellow, the green, and the red in that order would be this possibility. So I would have 1 success out of 6 possibilities. Now another way to look at this is just with kind of what we call the fundamental counting principle. If you keep in mind that probability is nothing more than total successes over total possible, then we could look at this as sort of different events. We could say, okay, I want to pick the yellow, the green, and then the red. The yellow, the green, and then the red. I'm going to write it this way. Well, what are my chances to begin with of pulling out a red ball? There would be 1 out of 3 balls would be yellow. Now, if I put that ball back in the bag and I want to pull out the green one, then there would be 1 out of 3 possibilities. Now, if I put that ball back in the bag and I want to pull out the red one, there would be 1 out of 3 possibilities. We could multiply these together, these individual events, we can multiply them together to get 1 out of 27, which is actually a much easier way of figuring the probability rather than trying to draw out the tree diagram. Now this works the exact same way even if you're talking about without replacement. So here again, I want the yellow, then the green, then the red. So if I want the yellow one to begin with, that would be 1 out of 3 possibilities. But now remember, I'm going to take that yellow ball and I'm going to set it to the side. I'm not going to put it back in my bag. So now my bag only has 2 balls left in it. And the green one, if I pick that out, that would be 1 out of 2. Now I'm going to set that to the side. So now in my bag I only have 1 ball left, and it's the red one. So there's 1 out of 1 possibilities left in the bag. If I multiply these together, then we end up with 1/6, which is the same thing we got by drawing out the tree diagram. This just happened to be a little bit easier way of going about it.